Hi, guys. Welcome to the Advanced Refrigeration Training Podcast. I'm your host, Kevin Compass, along with my partner, Brett Wetzel. Today's episode is sponsored by Westermeyer Industries, the leaders in oil management and pressure vessels for the commercial refrigeration industry. Whether you're involved with designing a system or tasked with servicing one, Westermeyer Industries has been helping meet the needs of customers like you for the past 20 years. We offer a broad catalog of stock system components with an in-house team of engineers to assist with custom solutions as well. From oil separators and heat exchangers to system monitoring devices, Westermeyer Industries are total system specialists with industry expertise, engineering know-how, and the manufacturing muscle to help you tackle problems and deliver solutions.
Good evening and welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. What's going on?
Well, since we recorded last, I think it was like Wednesday, or no, it was Tuesday. I'm in my fourth state now of the week, and it's Thursday currently. So I am, yes, in my fourth state, just driving all over the place and just hit some rooftop programming today, and hopefully in the morning, just got to show the customer what's up, how it works, and I am out of here and hopefully headed home. You?
I'm still in San Antonio. I had another day of RDM training. I am doing some training tomorrow with some of the guys. I don't know what else I'm doing. No, that's about it. By the way, we finally hit 2,300 downloads, so congratulations to us. But today we're going to be talking about actual oil trouble. The last podcast we did intro to oil, basically explaining the low pressure system, high pressure system. And tonight we're going to get into diagnostic because, as most of you guys know, diagnostic of oil systems is usually the highest rate of callbacks on most refrigeration contractors.
Yeah, which I'll agree. I mean, it's oil diagnostics is probably one of the harder parts about this job. I mean, it takes the longest to learn, it seems like. But me and Brent are going to go over some things we follow just about every time and try to do with every oil failure call to try to getting the callbacks, being more thorough, actually figuring out the real problem that's not adding oil.
You want me to start by explaining some of the older oil fill controls?
Yeah, sure, take it. You got a little bit more time on me.
So usually on the Copeland compressors, we have the Centronic. Now it's up to the Centronic 3. What's nice about the Centronic 3 versus the Centronic 1 and 2, basically have an input for the voltage that it doesn't really matter. You can hook it up 120 or 240 and it'll still function. There's no separate terminal for the separate voltage. Typically, everyone thinks that the oil sensing switch is a transducer because the plug on the back does in fact look like it looks like a transducer. But if you actually unplug it and look at it, there's actually only 2 wires that are connected to the oil fail device. That is just an oil differential switch. So it's either open or shut. Typically the way it works is on a Copeland compressor, you try to maintain more than, I believe the cutout is 9 PSI differential between the crankcase and the oil pressure. If it's less than that, what'll happen is after 120 seconds, the oil fill control will actually open up the control circuit and interrupt the compressor. You have some other oil fill controls. You have the Johnson control, either a 345 which is the older version. You also have the 545, the newest version that they have. There's 3 lights on that one. You have a red light, which means failure. You have a yellow light and a green light. The yellow light can mean one of 2 things. If the yellow light is on by itself, that means that it is timing for an anti-short cycle delay. If you take off the 4 screws off the front of the oil fill control and you look inside, the jumpers in there, jumper can be set for 0 to 30 to 60. So I believe it's either 100 or 120. And that's actually the short cycle delay. So when the compressor contacts want to pull in, let's just say the RO turns on to start the circuit, there's a delay in that oil fill control where it's actually not going to come on right away. And you'll see the yellow light just start to blink by itself. Now you have to be mindful when you're actually setting one of these up. If you're on a single system, no harm, no foul. You can delay it as much as you want to have essentially an anti-short cycle delay to make sure that we don't cycle our compressor. But if you are dealing with a rack, you are setting this up, it's highly recommended that you actually put the delay down to zero seconds. The reason for this is a lot of systems have a proof failure. And if the proof failure is set for 30 seconds in the EMS, in the energy management system, where the compressor doesn't come on within 30 seconds, the system will fail. And basically it will stop trying to bring on that compressor. So if you have delays for 30 seconds or 60 seconds, basically it's not going to turn on right away. The EMS is going to fault out and then turn off the RO for that particular compressor and not even bring it on. So it's highly recommended to not even utilize that delay and just put it to 0 seconds. So with the delay, if you do have a system that has a delay, you'll have the yellow light stay on. It'll start blinking for however long the delay is. And then what'll happen is the green light will kick on as soon as the compressor starts making oil pressure. If you see on that particular control, if you see the green light stay on and the yellow light actually start to blink, that's telling you that you're below your oil set point, whatever the differential is. So let's just say Carlisle, it might be set for 6 PSI. So if you're less than 6 PSI on a Carlisle compressor, what'll end up happening is the yellow light will start blinking while the green light is on. And then after 120 seconds, it'll fault out, shut off both yellow and green lights, and then basically just kick on the red, open up the control circuit, and now you have no compressor running. Those are some of the controls that we use. There's also another one made by Cure One. It's called the Delta P2 gauge. That particular one is predominantly used by Bitzer, but they do make different ends for the actual fitting that actually goes in the compressor. Same thing with the Johnson control. They actually have different fittings where like a Copeland one is a lot longer than what a Carlisle one is. A Bitzer one is a lot shorter, but it also has, if it's going on a Bitzer, chances are it's probably metric threads. And like I said, those are just switches, differential switches. So that really kind of dictates basically when the oil pressure switch is going to open or close and actually fault out the system. So you could have the same control as you would use for a Copeland or 545, but the only thing you really have to change is the actual fitting that actually goes into the compressor. The Delta P gauge works exactly the same way. Some have a resetting button on the back end, and then there's other ones that do not have a resetting button. And if the system were to fail, then basically you'd have to drop the control power to activate that. It's similar to like the compressor control module that's in the Peckerhill compressor that overheats. If the windings overheat and that particular item opens up, it will potentially fault out, and then to reset that, to drop the control power and turn it back on. There's also one other type that Cure One, I believe it's an Opto 22. And that one is for Bitzer compressor that does not actually have an oil. One that has, we talked about yesterday, or last podcast, we talked about the different styles of compressors, whether it be one that has an oil pump or a sling style. Well, the Opto 22 actually goes like directly in the center where the crank is. And what it's doing is actually an optic eye, and it's looking for oil. There's no oil pressure there. It's basically seeing if there's oil in getting thrown around that compressor. And that works. It will turn red, blink red when it's failed. And in order to reset that, you'd have to drop the control power, which will turn that thing back on. Anything you want to add to that, Kevin?
Yeah, so the optical eyes, two things. They will trip on oil if the compressor is overfilled. If it doesn't see the splashing and it's overfilled, it will also trip on oil. And actually three things. The second thing is if the oil is foamy, even if it's not flood back, if it's foamy, like it's foaming coming into the float, it will also cause the eye to fail out, prematurely, even though there's oil in the compressor. And with flood back, it'll also do. There was a certain date code of those too. I don't remember exactly the date code. I just know it was like a couple of years ago. There's a certain date code range of those controls that were actually faulty. They were timing out like 10 seconds. So that's one thing to look out for when you're looking through those I ones. I am not a fan of those. To be honest, I'd rather just have an OMB.
So since we're talking about foaming compressors, I don't know how many times I've seen on supermarket TikTok where people are seeing foam inside the plate glass and the oil. Can you explain why that happens? What that actually is from?
So that could be from a few things. Obviously, it could be from flood back, like everybody thinks, from the refrigerant boiling off there, or it could be just from when the compressor starts. It's lowering the pressure in the crankcase, so any vapor that or anything inside of the oil, any refrigerant in there is now boiling off, which causes a little bit of foam, even though it's not flood back, but it's causing the refrigerant to boil off inside of that oil. Or two, it is oil actually coming inside through the float. It's metering in. It could be low flow on the oil. It could be oil with condensed refrigerant in it. It could be just oil coming across the port that's barely open on the oil flow. Those are all the reasons it can start foaming.
So since you're talking about refrigerant actually condensing in the oil line, I want to kind of elaborate on that because a lot of experience with this in multiple different ways. So Tyler, for a little bit, for some odd reason, we talked about the different types of oil separators, right? And we said that typically if you have what's called a turbo shed, which is basically a helical separator or a coalescent filtered separator with no oil float on the bottom, we consider that a high pressure system, right? Well, instead of the oil leaving that separator and going right through an oil filter, oil regulating valve, back out to the compressors, Tyler, for some odd reason, was putting a oil reservoir at the rack as well. I don't know why, because basically, like we said before, a turbo shed is basically its own reservoir. What happened was I was up in Connecticut and this rack was right next to these automated dampers that were supposed to be closing. They weren't closing all the way and was making the machine room come down to about, I don't know, probably 40 degrees. Well, what happened was because the separator is hot, okay, you might be running, let's just say 75 degrees saturated in the wintertime, right? As far as your saturated condensing temperature, which means anything over 75 degrees, it's going to be technically vapor, right? So normally the oil separator, 120, 130, 140 degrees. So you're well superheated, so you're not going to have any liquid form. Well, this oil reservoir, because it's piped off the actual turbo shed, off the actual separator, this refrigerant was just sitting there getting cold. So the pressure in the reservoir, because in this particular system, there was no OCD on the top to drop the pressure down. So basically the reservoir was getting down to 40 degrees, but we're still at 75 degrees saturated. So that would make it 35 degrees of subcooled liquid. So any vapor that was in there would actually drop below the oil because the liquid refrigerant was actually heavier than the oil. It's almost like oil and water. And then instead of the compressors getting oil when they called for, they were getting straight up liquid refrigerant. If you check out the refrigeration group, Advanced Refrigeration podcast, I have a picture up right now where you can see the oil regulating valve, the 1236, actually looking like an expansion valve. And this was all because the motor room was getting too damn cold, condensing the actual refrigerant on there and then sending that liquid refrigerant into the compressor, and then causing oil failures because they weren't actually getting oil. They were getting liquid the whole time.
Yeah, we have that problem a lot. It's been at that probably 30 or 40 rack in a box racks up here. High pressure oil system with a external reservoir. It actually looks like a receiver, and it does the same thing all winter long up here. Rack in a box on a roof, exposed to the ambient.
Yeah, we cut the last one out. I don't understand why the turbo shed, like we said, is basically its own oil reservoir. So as long as the compressors are filled up with oil, and as long as the turbo shed has a good level, I don't understand why you would need that excessive amount of oil. Yeah.
So I was told every one of these has 5 larger scrolls. So I was told it was because there was such a demand on those scrolls, and they could basically wipe out a turbo shed with one
Really?
bill. Yeah.
Hmm.
If a turbo shed sitting at one ball, fine, was empty and goes full fill, it'll wipe it out with one fill.
Hmm. No, we just
If you use like a ZF-18 or something like that, or a ZB-18, that's a small compressor. I mean, especially when you get the smaller separator sizes. I mean, some of those smaller turbo sheds don't hold very much oil. Maybe like a gallon, and you're up at the second ball.
we got you.
So that's why I was told I did it. But I mean, that's a horrible idea. If you're going to do that, you need to eat and insulate it.
And basically put it on a thermos. You don't want that thing rolling the whole time during summertime. It's a waste of energy, and there's no reason to even have it there.
Well, let me tell you a quick story about that.
Good.
We were doing a startup, and that was the rush job. It was a Thursday into Friday. And then there was a main liquid line cylinder on this rack, and nothing was programmed to it. So it was overridden. Something happened. The override got taken out. Rack went down, pumps down over the weekend. Receiver was too small to hold the charge. So it just kind of went till it high headed a little bit, pumped down. Well, lo and behold, I mean, we did a quick startup here, didn't check everything. And one of the things I always check, and I'm pretty diligent about it, is the receiver heater. Well, somebody at Hill Phoenix, when they installed the thermostat in here, they had the band heaters on there. They had it set for 160 degrees.
Nice.
It was 95 degrees outside. So this full receiver sat at 100% with the liquid line shut off on one side, the condenser full of gas on the other side, and sat there baking their refrigerant until it blew the release off. So until the whole rack was flat.
Amazing.
Yeah, so that's one thing you may want to check when you're doing stuff is you shouldn't leave heat tape on a vessel without a thermostat. Check it.
All right, back to oil failures. Some of the things you have. Let's talk about low pressure systems for a bit. We explained before that basically you have to have 2 pressure drops in order to have flow, right? Your discharge pressure that goes to your oil reservoir, which is typically going to be anywhere from 5, 10, 20 to 30 pounds heavier than what your highest suction is. Well, there's your intermediate pressure, and then your crankcase is basically the lowest pressure where that flow is going to end up going into that compressor. You want to go over some of the issues that can happen?
Yeah, so let's start with the low pressure oil system. So first things first, when I'm looking at an low pressure oil system, I'm going to look at the reservoir, see if there's any oil in there. If there's no oil in there, and I'm going to venture over to the oil separator, and I'm going to feel a feed line feeding out of the oil separator. First things first, your hands before you get any tools out. Feel that feed line. Is it cold? Is it hot? Is it like boiling hot? Is it warm? Is there an oil sight glass? Can you even see any oil sight glass? You see oil flowing through there. You want to check those things first. Do a quick visual. And if you see no oil in there and the feed line's cold, then I start digging deeper. So the first thing I'm going to do is I'm going to check my reservoir pressure. Because if your reservoir pressure is high, say it's 150 pounds or just 250 pounds, and your rack's running just about that, you're not going to flow any oil on the separator in order to feed oil your pressure on the reservoir to feed oil from the separator into the reservoir. So you got to check that OCV valve. If that OCV valve is a 10, a 20, a 15, a 30, whatever it is on there, that should be 30 pounds above. If it's a 30, your whatever suction grip is tied to. So if it's not, your suction is maintaining 50 pounds and your oil reservoir is 125 pounds, well, that's a problem. You're not where you're supposed to be. So you need to verify that first. once you verify that it isn't suction pressure, it's completely pumped out, then you need to watch the separator for a little bit. I'll strap a temp probe to it. I like to throw an EMS temp probe on there and set the logging up for like 30 seconds and just make a sensor control so I can watch it. If it is an issue, I can just graph it out on the controller to see if it is feeding or not. So I'll just watch it. It'd be like 30 minutes, see how many times it cycles. It should cycle anywhere from like 5 to 7 times an hour. Usually what I see them do, depending on how much oil you're putting and how much you're separating. So if it's not cycling at all in that time, you probably got a stuck float. I would at that point probably drop the float and you'll pump the rack down, drop the float. Brett's going to go over how to float or to get you out of a pinch. I mean, I see guys beating on them and kicking on them. That hardly ever was. You're probably just going to end up causing some more damage than anything. But Brett's going to go over a way on how you get some free will. Like you need to eventually pull that float down and clean it. It's probably dirty. I've seen a few that are crushed. I've seen a few that have holes in them that, they have oil in them. So I always make sure to clean them. I flow brake cleaner from the 3/8 line through, and then where the needle is, I'll flow brake cleaner through there, make sure I got full flow of brake cleaner. And then I'll take the ball and hold it in my hand, and I'll shake it back and forth. Try to hear anything in the ball. If you hear something inside the ball sloshing around, you got oil inside there. It's not going to pick it up.
Correct.
The float is kept at that point.
Yeah.
Now,
the other thing I've seen, someone actually posted a picture on Supermarket Refrigeration Tech Talk. There was a ball that looked like it was crushed. Typically what happens is when you see that, if you end up dropping the float and you see that ball actually being crushed, typically you should have a discharge check valve on the outlet of your separator. Okay. This is when the rack actually shuts down to make sure that liquid refrigerant doesn't come back in your discharge. If that check valve were to fail, or if there's not one there, basically liquid refrigerant can basically migrate upon a failure. And then what will happen is when you start that, if you do in fact have that separator full of liquid, the liquid's going to expand quite rapidly and potentially crush that ball. I've also heard of one particular store where I'm pretty sure that the separator had actually blew apart, and someone ended up getting injured because of this. Rack for a little bit, rack started back up, separator blew apart. You have to be very careful when you're starting something up back after a failure. You want me to go over how to backflow it if it's not?
Yeah, you want to hit the backflow thing?
So if you have to backflow, you know that it's probably it has junk in it. Definitely probably dirty. You should probably make plans on changing it anyway. This is just to get you out of a pinch. Typically, technicians try to put another oil service valve right next. There's usually a square plug that's in the bottom of the separator plate, right underneath the float. And that way you have something there to try to drain out that oil, because if you assume that separator is filled up with oil, you want a way to drain it out. Unfortunately, sometimes they're not always there. This is a way to actually backflow the separator to get you out of a jam until you can get someone there with a new float assembly. All right. You might need to write this down. There's a couple directions that you need to follow. First thing that you're going to do is close off the oil outlet on your reservoir. The reason why we do this is because we are going to pressurize the reservoir, and we want to make sure, like we stated before, a lot of the oil floats, they don't like greater than 90-pound differential. So if you do in fact have greater than 90 pounds, you're going to damage the float and cause even more pain and suffering than what you're already going through right now with the rack being. Next, you're going to follow where the OCV is connected on the header. You're going to close that line off. All right. Hopefully you got at least one compressor you can start running. I would want you to hook up a discharge line from the discharge of one of the compressors that you have running. and run that into the reservoir. Okay. Turn off your condenser fan motors. I want to get the pressure in there as high as humanly possible. Okay. Let's just say your head pressure shuts off at 325. Try to get like 300 PSI worth of pressure from the discharge from your gauge manifold set into that reservoir. So now we're going to, after we closed off the OCV, now basically it's closed off from the outlet. It's closed off from the OCV. So the only line that should be open or even cracked is the top. So you can actually pressurize that reservoir with discharge pressure. We're going to get that thing up to about 300 pounds. We want to make sure that when you shut off the gauge set that it stays up 300 pounds. Once we get it up to 300 pounds, then what we're going to do is going to run over and turn on the condenser fan motor. Because right now you have 300 pounds in the reservoir. You have 300 pounds in the separator, right? When you drop the head pressure by turning on your condenser fan motors, the pressure in the separator is going to drop. The pressure in the reservoir isn't going to go anywhere. It's going to stay right there. The idea is once you turn on the condenser fan motors, that 300 pounds that's now in the reservoir is now greater than the pressure that's going to be in the separator as the pressure comes down. So the idea is that 300 pounds is going to help push whatever junk is left in the 3/8 line going into the actual reservoir, and actually punch a hole through whatever junk is in the bottom of that float. It might not work the very first time. Do it a second time. If you see you'll see if there is a slick glass on the system, when it starts flowing in the opposite direction, like once the pressure's rising, you'll see the reservoir start filling up with oil, but you'll also see a whole bunch of dirt come out of the actual oil separator. Like I said, this isn't just to do this and leave the rack running. You know that there's junk in the bottom of that separator. Okay. This isn't a permanent fix. This is just to get you out of the woods. So when you do have to drop oil float at the bottom of the separator, you don't get covered in 8 gallons worth of oil. That's all this is for. Just to get you rolling, to get the oil out of the separator. So then you can have someone bring you a float. So you can babysit the rack until someone can get you a float and then shut it down and then actually change out the float and do a proper fix on it. At that point, you're probably going to have to change your filters as well. Then once you're all done with that, you get oil back in your reservoir. You got oil back in your compressors. You would have opened up your OCV to relieve off any remaining pressure that would be in there. And lastly, you're going to open up the oil line going out to your compressor. Then that way you're not overpressurizing the compressors and filling them up with super high discharge pressure. That's why we're going to open up the OCV first before we open up the line out. And that is a way to actually, get you out of a jam in case your oil separator float is not opening up all the way then when it's filled up with garbage.
Yeah, that's a good way to do it. Or you could be like everybody else, just speed with a hand. That's just that does not work. Just so we're throwing it out there. That's pure luck. But I've seen so many guys do that. So yeah, that's a good way to do it. I mean, I tend to always, if I don't have a float, I at least have a gasket on my truck. So I can at least drop the float and at least clean it. Generally, you could get it clean. I mean, it's pretty rare for the ball to fail, but it does happen. So when you're taking the bolts out of these flanges, so obviously leave 2 bolts in there and then get all the back bolts out first. And then what I like to do is loosen the 2 side bolts and then pinch the back of it. So like the very front of it opens up a little bit. The oil will start flowing up forward. I do not like to use a pan to catch it. I use what's called a pig funnel or like a formal funnel. It's basically a lead funnel covered in rubber. You can basically like mold it to whatever shape you need. I mold it underneath there and you'll generally catch all the oil into like a bucket or something. So that's how I like to do it, to make sure you don't take the last 2 bolts out and get an oil bath. And then as you drop down the separator, so it depends on what kind of separator you have. If you have an impingement type separator, there's a couple things you need to look out for. You need to look at the float, obviously. But you also need to look inside the separator, and there's a screen around that protects the float. Okay, that gets plugged up with dirt and debris too. So you need to pull that screen down. It should be like a circular screen around where the float sits in. Then you need to look up inside of there with a mirror or a camera or your head. And there is a cone-shaped screen inside this thing. That is what actually separates. It's on the discharge line, comes with the compressors. That is what actually separates the oil. So the oil and discharge gas come through the screen, okay, and it causes it to aerate. Gas goes up, liquid oil comes down. Oil's heavier than the gas, so it falls down, and it collects by the float until it has enough down there, and it raises the float up, and then it goes out to the reservoir. It is crucial that that screen not be torn. You lose a compressor, you bust up some valve plates, broken material, trash, anything that goes to that compressor ends up in that screen. So if you get a broken compressor and you can't find the valve plates, like if the discharge reeds are gone, if the discus bag is gone, guess what? It's not stuck in the muffler or the baffle plate in the compressor. It's in the screen of the separator. And it's probably torn right through it. So you need to look up in there and make sure your screen's not torn. I've heard of guys being able to change those screens. Me personally, I could never get my arm in there. So I don't know, Brent.
No, absolutely not.
So it's got like a hose clamp on there, but like I'm not getting my arm up in there. That thing's smoking hot. Not to mention
I'm fat and I'm not a contortionist, so there's no way I'm getting my ass up there.
Yeah. The fire department having to cut separate my arm stuff. I'm gonna give you guys a trick on how to get this back going, especially like in the middle of the night or an emergency or like till you get another separator going. But go to the manager's office, go get a stapler. And if the screen is torn, you staple the living shit out of it. Like a bunch of staples. And that sucker will run for a while. Matter of fact, I know one that I stapled 2 years ago that's still running. They were putting a separator on.
I've never done.
So that'll get you back going to the pinch. Is stapling.
I don't think I've ever come across actually one that's been real. Never. Yeah.
Really?
No.
I see it all the time.
Most of the separators that I've done is either for or some coalescing. So just sheer luck that I guess that I haven't seen my fair share of impingement screen.
Yeah, we got a lot of older stores over here with the chain store. Like they have a lot of older racks, 90s, that have a lot of impingement style screens. Matter of fact, I just staple one back together. Like,
you make me feel really old when you say, "Oh, they're old. They're from the 90s."
Oh, you want me to say it's really old? All right, so that's one way to get an impingement style screen separator back going. Other than that, you got to change it out and don't put an impingement style back in. Impingement style separators are only like 75% efficient catching oil. You're much better off with a filtered type or a centrifugal, or heel coil, as preps call them. You're much better off with that type of separator. It's going to be much more efficient, and it's going to protect you from tearing that sock. You won't have to worry about that again. So once you have proof, so if you drop that float, there's no oil in there, and the sock's not torn, you have another issue. Not so much either low on oil or your oil sitting in the system. If you go to pull that separator down, Henry and ACR, they all list the amount of oil that's supposed to be in there. But if you pull that plate down, there's not any oil in there, barely like maybe an inch. You have an issue in the system. Like you have a system issue. Or the oil's all over the ground. I hope you would see that. You have a system issue. But if you pull that thing and it's full of oil, gallon, 2 gallons, you got a float issue. So that's one thing to look out for. Now, after you get everything put back together, you put like maybe they list the ounce in there. I usually put like a quarter gallon in there, half gallon. I want to charge it up enough where the ball is going to lift up. So I want to be able to see that oil when I turn everything back on, shoot out of that separator and into the reservoir. So I want to be able to prove that the flow is working. So I don't have to sit there and wait for it to work. I want to be able to prove I want to see it fill up the reservoir. So then, your oil flow is good to the reservoir. Then you want to check your reservoir pressure against suction pressure. You should be at what your OCV is. Now, to test the OCV on the oil reservoir, this is how I do it. I shut off the outlet going to floats. It's very important, or else you'll mess the floats up. You're going to shut off the line feeding the oil separator from the oil separator to the reservoir, and you're going to take discharge gas and fill up the reservoir with it. And it should vet out whatever it is about the suction pressure. If it's 30 or 20 pounds, it should be 30 pounds above suction pressure. And it should hold pretty steady. I mean, if it bleeds down right away within like a minute, then the OCV is bleeding through. If it stays longer, like 10, 12 minutes, like it's good. It should be above whatever it is.
Yeah, and if you pressurize it with discharge gas, like you stated before, and it stays up to wherever the discharge gas is with the OCV still open to the suction, you have basically that OCV is failing to open up and relieve that pressure. Like you said, it should just be, if you have a 20-pound suction and you have an OCV 30 in there, your expected pressure in your reservoir should be 50 pounds. If it's not with the steps that he took, OCV is probably bad. Next thing after you prove that so now we know we have oil coming out of the float. We know that the OCV is regulating the pressure into the reservoir properly. The next thing you probably want to check is to make sure that our filter isn't restricted. Filters usually put on the outlet of the reservoir. You're not really going to be able to see any kind of temperature drop because you're basically going to be discharge temperature, or whatever the temperature is. It's basically really not, there's no refrigerant to make a temperature drop, but you will definitely see a pressure drop. What do you say? 5 pounds of the differential and time to change it?
Well, I mean, unless the floats are calling, you're not going to see that. So this is the way I look at it. Like, I hardly ever see a drop through even when they're plugged, unless they're really plugged and all the floats are calling. When in doubt, change it out.
So we talked about the helical separator, the turbo shed, what we refer to as basically that's a separator that does not have a float at the bottom. There's usually always sight glasses on the side. Sometimes on the older low temp racks, they're really, really dirty and it's kind of hard to see where exactly the oil level is. But you'll either have a helical style turbo shed, or you might have one that has a coalescent filter. Helical separators, like we had stated on the last podcast, are CFM rated. If you are less than half of what the total CFM rating is, the capacity starts to dramatically drop and it will not separate that oil. Basically, that refrigerant oil, when it's piped into the separator, is spinning around at a certain rate. It's almost like a blood centrifuge, right? It separates the blood cells in there, but same principle, and it separates the refrigerant from the oil. Oil's heavy, drops down the bottom, fills up the reservoir section of the actual separator, and basically goes out from there through into an oil filter, and then would basically either go to a high pressure style oil level control, like an OMB control, or if it goes into a conventional oil float, you'd have to drop down that pressure. There's two different types of valves that you'll see that are made by Sporlan. one has a Y1236. Can't really explain what kind of like it looks like, you know what? It looks like expansion valve flared on both sides. The only difference is on the top, looks almost like a EPR adjustment stem. EPR adjustment dome. The only difference is on the top, there's a 1/4-inch line that goes to wherever suction that you're connected. And that valve is set from 25 PSI differential, 25 being the max. Is that correct? And then
it is.
from there, you would go to your oil level controls, with your oil pots. So it knocks down the pressure. Remember, we don't want any more than a 90-pound differential on 99% of the oil floats. And there is also another style valve is made by Sporlan, but it was specifically made for Hussmann. Once again, this looks exactly like an expansion valve. The only difference is this has a flat power head, and basically the capillary tube that's connected to the top of that power head is then piped and welded in to the front. Towards the outlet of the valve. And that is helped and utilized to adjust that oil pressure to get you your 5 to 25 pounds heavier than the suction that it's attached. Anything you want to add?
Oh yeah. One thing, the Sporlan Y123 valve does have a screen in it. So it has a flared PXV style screen. So that's one thing you take into consideration. If it's not beating, you need to check the screen. The Hussmann valve does not have a screen. So if you do get debris in there, you need to make sure you take it apart and clean it. So next, I want to go real quick over oil filters. So couple different kinds of oil filters. You have a Sporlan OF303. You have the OF303B. I do not like to use bypass oil filters on anything. I would rather the filter plug up and the rack go down than the bypass go and then nobody knows the bypass is going. So I generally like to know the filter's plugged. So I don't like to install bypass oil filters. So I like to use the OF303s, not the B style, the bypass. And then you also have the SF283, which would be it'd be a suction filter, a Sporlan suction filter. You see this used a lot on Hussmann equipment, older equipment.
Protocol.
Before they had oil filters. Protocols. Hussmann still sends racks out today with them. So if you see an SF283 filter, don't freak out and think you can't use it for oil, because you can. I mean, they tend to plug up a little faster, but they usually are a little cheaper. I mean, if I get a real dirty system and I'm going to be in the process of cleaning it up, I'm going to use SF283s because I could change them more. And they seem to plug up a little faster and get a little more out. And then you have the replaceable cartridge filter, the
OFE1.
drawing a blank. Yeah, the OFE1. So you have the OFE1, which is the replaceable Sporlan cartridge filter. And now Westermeyer actually has a replaceable cartridge filter also that you don't have to take apart like the Sporlan one. The fittings are not on the top. The flanges are all on the top. We put them in on a rack, and the flanges are on the top. So you can pull the bolts off without having to take the flares off. So that's another option for oil filters. Emerson makes an oil filter too. We don't really have anybody that sells Emerson stuff around us. So that's about it for oil filters. I like to see them change at least once a year. I like to see them changed, if not more. Changing oil filters is better than not changing oil filters. The cleaner you keep the oil, the better everything is.
A lot of times when we're doing PMs, there's certain things that I honestly don't even have people. Liquid cores is a prime example. Oil filters just automatically assume that if the customer only does one here, just change. If the oil looks dirty and dark, then that means at that point you should be doing an oil change. But yeah, on a PM, just regardless, just change it. Like before.
Yeah, I mean, nothing bad
No,
comes
not
out
at
of
all.
changing oil filters.
One thing I do have to
Over
mention
to it.
about the 283 that you had brought up. I actually just purchased one for a protocol. We were working in a protocol at a gas station, and it's actually a biflow valve or a biflow filter.
Yeah, so it matters which way you put
It does.
Yeah. So one direction will be, it'll say bypass. The other direction,
I was
without
trying to figure
bypass.
out why they actually use, because I mean, usually on a protocol, you have the turbojet goes to the oil filter. Is that
It's
why?
cheaper.
Okay.
Yeah. It's half the cost.
Gotcha.
Like everything. Cool.